So, hello, welcome all to this Nullcon webinar session. My name is Harshit. I'm a part of Nullcon team and your host for today's session. The Nullcon conference is a unique platform for security companies and evangelists to showcase their research and technology. Today we have with us Abhisek Datta, and he is going to present his talk on securing microservices at API gateway using cloud native solution. I welcome him to this webinar session. Abhisek Datta is an accomplished security professional with over a decade of experience in information security, solution engineering, services, vulnerability research, reverse engineering, and security tools development. As a security researcher, he has credited with multiple vulnerability discoveries across enterprises products. He is also a regular trainer at Nullcon and many other well-known conferences around the world. Our today's webinar duration is about 30 minutes. After that, we will have a question answer session. So you all can ask your questions after the talk using chat option. I also request you all to keep your mic on mute during the session. So Abhisek, welcome again, and the stage is yours.
Thank you, Harshit. You already did the introduction. I had a slide about me, but I guess I have to skip that. Okay, I'll go ahead and start. Hey, hello everyone. Thank you so much for joining the webinar on securing microservices at API gateway using cloud native solutions. Good morning, good afternoon, good evening, depending on wherever you are. That's the fun of webinars. You never know who is joining. Thanks to Nullcon for inviting me for this webinar and getting me a great crowd to listen to what I speak. I have an introduction slide here, but I guess Harshit already did most of it. But just want to add that I am part of NULL, which is India's largest open security community as a contributor. If you're from India and if you're interested in various kind of security meetups, do check out our website null.co.in. Apart from that, I also do a lot of open source contribution. You can check out my GitHub. Currently, I am working as the head of security products at AppSecO. We are an application and cloud security company. And lately, we have been doing a lot of Kubernetes cluster security assessments, something which I am doing personally. If you follow me on Twitter, you will see I tweet a lot about Kubernetes security lately, right? So, I mean, after this talk, I will share my slides with Nullcon team as well as I will post them on Twitter. Beyond the Q&A, you can ping me anytime on Twitter, and if you have any feedback or suggestions, feel free to let me know. Cool. So let's get started. For this session, the key takeaways will be, we will first establish the need for centralized authentication and authorization. Why should we do this? What are the challenges in microservices authentication and authorization, and why should we think about centralizing them, right? Then we will understand the role of one of the key component in a microservices architecture, the API gateway. We will see how we can use the API gateway as a security gate, particularly to implement security controls like authentication and authorization, right? And finally, the most important part of this webinar, I will demonstrate and talk about a proof of concept implementation of doing centralized authentication and authorization at API gateway. I will demonstrate this. I will show the code, and I will also share the code with everyone so that you can take it, understand, and build your own, right? So for this demonstration, I will use traffic as the API gateway, and I will use something called Open Policy Agent as a service for policy management and evaluation, right? Just to set expectation, this is not going to be an introduction to microservices. Particularly, we will only look into this authentication and authorization aspects of microservices, how it is usually done, and what is a proposed way of doing it in a centralized manner, to make the overall system more secure, right? So I will not talk about the fundamental microservices patterns or anything like that. But if you are not familiar with microservices, you can probably check out this great site called microservices.io. They have a bunch of introductory articles and patterns on microservices. So I think if you're interested, that's a great place to start. Okay, so let's first establish how authentication and authorization conventionally works in a microservices environment and what are some challenges from a security perspective. If you see, conventionally what happens is that there is a client and there is a reverse proxy, and this behind the reverse proxy there are a bunch of services which forms the microservices architecture for given platform or an organization. Usually for an unauthenticated client, the front end redirects the client to another component called the identity provider, right? And examples of identity provider can be Google identity provider, or say Azure Active Directory, or Auth0 or Okta. There are a bunch of ready to use identity providers out there, which people usually adopt instead of building something from scratch. So in a microservices environment, what happens is that the identity provider will authenticate a client using credentials, two-factor authentication, or whatever is required, and issue an identity token. Usually the OAuth flow is used in order to interact between the client, the identity provider, and the requesting application, right? And again, usually the token is in a JWT format and following the OpenID Connect specification, right? So this token issued by an identity provider is used by a client in order to authenticate itself to the various backend microservices, which resides here. Now, for these microservices to trust this token, there has to be some established trust between this microservices and the identity provider. This is where JWT signatures comes in, right? So there is some kind of trust already established, either through a shared secret or from an identity provider's public key, using which this microservices can verify whether the token supplied by a client is actually issued by a trusted identity provider or not. So after obtaining JWT, an authentication identity token, if a client tries to access a backend service, say the product service, or the account service, or in number of services can be there, then each of these services will have to first validate whether the token is correct and whether the identity of the client is verified or not, right? Then each of the services needs to authorize whether the requesting client is allowed to do a specific action or not, right? So each of these backend microservices have to implement authentication and authorization on their own in a conventional architecture like this. If you look at it from a security perspective, authentication or authorization, which is probably one of the most important foundational security control, is now in conventional architecture is spread across a bunch of applications. So to secure this overall system, you need to ensure that each of these applications, each of these services correctly verifies the identity token, and based on the identity correctly authorizes an action by a user, right? Which if you look at in the past is not very easy to do, especially for a fairly large infrastructure with say hundreds of microservices. There has been many examples where authentication and authorization uh, was incorrectly implemented for new services, right? Old and matured services would do it correctly, but for new services, it may not be implemented correctly, and which kind of opens up attack surface. in a conventional microservices architecture, there is a reverse proxy whose role is basically just forwards requests from the client to an appropriate service. So there are multiple applications in the backend. This reverse proxy over time became API gateway, because in a microservices architecture, it was identified that there has to be a component that can accept all external requests, and based on certain attributes decide that this request is meant for which service and forward that request to that service. uh, so API gateways are basically reverse proxies with a bunch of additional features like observability is implemented, logging, analytics, rate limiting. Rate limiting is a common feature implemented in API gateway, right? So a bunch of these features are implemented, and this API gateway acts as the URL router, which routes clients' requests into appropriate microservices. Now, if you think of it, that this API gateway, from an architectural point of view, is placed in a location through which all requests to backend services are going. So why not we think of this component as the ideal place for enforcing authentication and authorization control? So what will happen is that we will centralize two most important security controls in the API gateway. So even if some backend microservice is not doing it correctly or does not implement appropriate security controls for authentication authorization, still our overall architecture will be reasonably secure, because any request that hits a backend microservice must go through the API gateway, and in our proposed architecture, we will do authentication and authorization in the API gateway itself. So think of this: any request which is going to one of these backend services is already authenticated and authorized before it hits the service, right? So from a security engineer's point of view or a security architect's point of view, you look at this component as the most important for authentication authorization, and you spend all your focus and effort in securing this, right? So we will see how to do this. So as part of the webinar, we will look at some cloud native tools on how to achieve this. Okay. For API gateway, I will use traffic, and for managing authorization, authentication and authorization rules, the policy is based on which a given user will be authorized, I will use a software called Open Policy Agent for policy management, right? So let's go ahead and see how this can be done. So we'll come back to this particular architecture. Let's start with the demo. Okay, then we will come back and evaluate how it is working. Okay, is my terminal visible? Can someone confirm?
Yes, we can see the terminal.
Oh, great. So let me bring up the demo stack, which consists of a bunch of components which we will look at. By the way, this demo setup that I'm using is open source. I will put up the GitHub URL in my slides. Okay, so the stack is up. Let's start by just so if you send a get request into the root of this website, it just says this is the website serving at / and available to all. So this means this is the public endpoint. Anyone can access this. But if you hit this endpoint API 1, you will see that it says you are not authorized to perform this action. And if you hit API 2, you will see you are not authorized to perform this action, right? So these two are protected endpoints, right? So let's for our testing purpose, let's craft a JWT. So before I do that, let me just quickly clarify that this is a very simplistic demonstration so that those of you who are watching this can get the idea. This demonstration is not suitable for a production environment as is, right? You have to adopt this approach and create for yourself in a secure manner. For example, I will craft a simple JWT token like this, which is insecure, right? For demonstration purpose, I am crafting a JWT token with one attribute called roles and a value called API1 users. There is no way to validate this JWT. Anyone, even attackers can craft a JWT like this. This should not be used in production. You must ensure that you use either HS256 or RS256 based JWT signing so that your client applications can verify whether a JWT is issued by a trusted identity provider or not. Okay. Just remember, this is for conceptual demonstration. This particular, the way of crafting JWT is insecure. So what I did is I just craft a JWT and store it in this token environment variable, which just has one attribute, roles, this, right? API1 users. Now, if I use this JWT to hit the API1 endpoint, you will see now I can access the API1 endpoint. Previously there was unauthorized, right? But if I use the same token to hit the API2 endpoint, you will see I am not authorized, right? So in addition to identifying a user from a JWT, it is also enforcing an authorization. It checks whether appropriate role is available in the JWT before allowing access to specific backend services. Okay. So to access the API2 endpoint, I have to ensure that my JWT has a role called API2 users. And now you will see I can hit the API2 endpoint, but I cannot hit the API1 endpoint, right? So what we are doing here is something like this. Our external user requests for /API1 endpoint. This request hits our API gateway, which is traffic. Traffic through some middleware. I will show what this middleware is. Through some middleware interacts with the open policy agent service and asks, is this request authorized? Based on the pre-configured policies, open policy agent will decide whether the request is authorized or not. If authorized, it will say, yeah, it's all good. And then traffic will allow access or route that request into the backend service, thus allowing access for the client. However, if the open policy agent says, no, this doesn't seems like authorized, then traffic will just reject the request. That particular request will not even hit the backend service. So effectively, the entire the entire requirement of authenticating and authorizing a request is taken away from individual backend microservices and implemented at the API gateway level, right? So tomorrow, if you follow an approach like this, tomorrow if your architecture needs a new microservice, you can just plug it in without worrying about authentication and authorization. Of course, there are other things you need to ensure. You need to ensure that an attacker cannot directly talk to your microservice. You need to ensure at network level through network policies that any request to your microservice must go through the API gateway. Only then it is effective, right? So let's look into how this is done, right? Okay. So this is how my Docker Compose file looks like, right? I have a bunch of component in the overall stack. I have the gateway service, which is basically a traffic API gateway. I have the open policy agent service. I have ignored this. This is for testing purpose. I have a middleware called OPA middleware. This is an interesting thing. This is basically a small web application, a web service which connects traffic with open policy agent. I will talk about this. I will show you how this works. Then I have a bunch of backend services. I have the web service, I have the API 1 service, and I have the API 2 service, right? So let's start with traffic. Okay. The traffic container. Oh, by the way, all of these are running as Docker containers, right? So the traffic container looks like this. I start from a base image of traffic 2.2. Then I just copy the configuration files and expose traffic on port 80 and 8080, right? So the primary thing is our dynamic.yrl. So this is how traffic configuration looks like. So I define some routers. So routers are basically ways through which traffic will decide whether how does a given request needs to be processed, right? So as you see, I hope the language is pretty self-evident. If there is a request that starts with API 1, then traffic should send it to service 1, service called API 1. And this is where the service is defined, right? Service API 1 is nothing but a load balancer service that balances across one URL. You can give an array of URLs here, and traffic will load balance any request meant for this service across the array of URLs. But in addition to this router and service mapping, I have also mentioned something called middleware auth OPA. So what is middleware? So traffic supports a bunch of middleware for transforming or validating input requests before they are proxied back to a backend microservice, right? In this specific case, I am using a middleware of type called forward auth middleware. This is a feature of traffic API gateway. This forward auth middleware allows me to tell traffic that decision to authenticate, or decision to decide whether a given request is allowed to go to the backend service or not can be offloaded from traffic. Instead of traffic deciding whether this is allowed, it will call this this URL to decide whether a given request is allowed, right? So that is what happens is that when a request comes and hits a route verifies where it should go. Before sending into the service, it will call this URL to determine whether the request should be processed or rejected. Based on the response from this URL, it will forward the request into one of the backend microservices. Using this middleware, we integrate traffic and open policy agent. So let's see how it looks like. If you look into the code of that auth OPA middleware, the traffic middleware using which we are connecting it with open policy agent, you can see it's a very simple piece of code. It handles a request at / prepares a input object. You will see basically we serialize this into a JSON. Prepares an input object for open policy agent service with some information like what is the method, what is the URI on which this request is hit, and what is the value of the authorization header. In this case, if the authorization header does not exist, then we set a dummy JWT. This is basically an empty JWT without any values. Okay. So this input is basically an input to the open policy agent service, which is listening here. So my traffic auth forwarder middleware, this application basically prepares a request input JSON like this and sends it here in the open policy agent service. And based on the response. If the response from the open policy agent service is 200 and the response body sets the value of allow flag, response body is by the way a JSON. Okay, if the response body has this allow flag set, then I will respond with 200 OK. This response is going to traffic. If I say a 200 OK, then traffic will know that this request is meant to be forwarded to a backend service. However, if I send a 403 forbidden, then traffic will just drop that service. It will not send it back to the backend microservice, right? So this is what this particular middleware is doing. Okay. So coming back, we have looked at how traffic is configured. Now let's look at open policy agent, right? Because that is where we are doing authorization controls. The open policy agent container is also very simple. I start with a base image of open policy agent. Then I just copy a static policy into the container image. And I start the open policy agent server with one single statically defined policy, right? So any evaluation that the open policy agent service will do will be based on this statically defined policy. So let's look at how this policy looks like. So if you look at this policy is written in a language called Rego. So Rego is a language I think created by Open Policy Agent, the company behind Open Policy Agent itself. So all policies for Open Policy Agent is written in this language called Rego. Okay. So what I'm saying is that by default allow is false, but I am defining two conditions in which allow will be true. If the first condition is that if the input path starts with API 1, if you remember in our auth forwarder middleware, we set the value of this input.path based on the information provided by traffic. So here the policy says if the input path, the request path starts with API 1 and there is a token and the payload of that token has a roles array and the role includes API 1 users, right? So this in plain terms means any request to API 1 must be allowed only to users with role API 1 users. Same goes for API 2. Any request to API 2 is allowed only if the requesting user has the role API 2 users, right? Now, where does this token comes from? Open Policy Agent has inbuilt library to decode JWTs, right? Again, just to mention, this is insecure because I am not verifying the JWT. This is only for a simple demonstration only. Open Policy Agent does support JWT verification with both shared secret or public key. So if you're adopting it for your own microservices, infrastructure, do look at how to verify the JWT before you make any policy decision using the JWT value, right? So this is what happens. The Open Policy Agent will apply this policy and make a decision and send it back. So these are the various components which is involved, right? I hope this makes sense. I will share the source code. If you have any doubts, please ask during the Q&A session, or you can ask me over Twitter as well, right? Demo, I think we have gone through it, and I have mentioned multiple times that you must verify and validate the JWT. We have also looked into the code. Okay. So if what we have seen is a very simple example of traffic, right? If you're interested in looking at traffic as an API gateway, do check out because it has a wide array of very useful features and it is very, very simple to adopt, right? it has one of the very interesting feature which I found in traffic is its dynamic configuration discovery. Like for example, if you deploy traffic in Kubernetes, and if you label your pods correctly, then traffic can automatically discover this backend services and URL routing information. You don't have to statically define it, right? And one of the primary things why I looked at traffic for this use case is because of its support for middlewares, right? I have not come across any API, any popular API gateway which with inbuilt support for open policy agent. Right? I guess in future a lot of API gateways will do that. Currently, traffic's middleware feature or similar feature in other API gateway is the way for integrating open policy agent as an authorization service in the API gateway itself, right? So do check out the documentation for the various features. Now, open policy agent. I think this is one cloud native tool that is becoming extremely popular due to its very flexible authorization policies. It's a Rego language, which is a very flexible language to define policies, right? One interesting thing about Open Policy Agent that I must mention here is that in my demonstration, I used Open Policy Agent as a server, which exposes an HTTP endpoint. You can interact with that HTTP endpoint to make policy decisions. You can send some input data, and based on the policies, Open Policy Agent will determine whether it is allowed or not and give you a response. If this mode of deployment is not suitable for you, and this is probably not suitable for very high volume infrastructure, right? Then you can also use Open Policy Agent as a library, right? If you have a custom API gateway of your own, then you can just use Open Policy Agent as a library inside your API gateway for policy evaluation, right? You can check out, there are some interesting ways you can discover policies at runtime, also discover as well as update policies at runtime. Okay. And Open Policy Agent is becoming an admission controller for Kubernetes as well. Like if you're familiar with Kubernetes, in Kubernetes world, you will see a lot of people uses Open Policy Agent to make extend RBAC for Kubernetes and apply other security policies on various Kubernetes resources, right? We are almost in time. Okay, about the proof of concept implementation, the code that I demonstrated is available in our GitHub repository under the AppSecO GitHub organization. Do check out the code if you are interested. It can be an interesting, a very simple and easy to adopt reference implementation on which you can build. And the entire idea behind this particular webinar is also available as a blog post in our blog. I have written about it in the past, like how you can do centralized authentication and authorization at API gateway, right? So this same proof of concept implementation is referenced in the blog post as well, right? So if you want to read about more, do check out our blog post on this. Cool. That's all for now. I hope this was useful. I tried to keep it short and concise so that we have some time to take up questions and answers. If you have any questions, do let me know in chat, or if you want, you can tweet me also.
Thank you, Abhishek, for this informative session. I'm sure the participant must have got some knowledgeable inputs from it. We already got some questions, so hope you can see that. Rohit Salecha has questions over chat.
Sure. Let me check. Authorization on URL endpoint, can you configure find and control based on parameters as well? Am I audible?
Yes, we can hear you.
Yes, yes, Rohit. You can implement very fine-grained authorization controls based on parameters as well. Just check out the Open Policy Agent Rego Playground. It has a web-based interface for you to try out Rego rules, write Rego rules against an input JSON. So you can easily play around with that. So Rego is pretty flexible when it comes to dealing with HTTP. So it has a bunch of parsers based on which you can make a policy decisions based on parameters or headers or other aspects of HTTP protocol as well. Okay. The second question: how do we check for authorization in microservices in post-based requests? What's the best practice? Kaushal, to answer your query, you can configure traffic, the API gateway, to send the post payload to Open Policy Agent as well, and you have to write appropriate OPA rules in order to investigate the post payload. This will not be generic. It will be very specific to your use case, like what kind of data you're looking in the post payload, and what is the attribute based on which you want to implement a policy decision. But yes, from a traffic and open policy agent point of view, this is definitely doable. Okay, can you send the blog links? Yes. I will share the slides in like 15 minutes over my Twitter account. So I mean, I think Harshit, you will also share the slides, right? Harshit, you are mute. You're on mute.
Yeah, I'll add that link over here.
Cool. Okay. So I will share the slide. So the slide will have the link to the blog post as well as the open source implementation for this. Please explore the link. Okay, cool. Awesome. Thanks. Any solution for API gateway for on-prem infrastructure? Dattatreya, to answer your question, traffic is a self-hosted API gateway. You can use it in your on-prem infrastructure also. I'm assuming I don't know what on-prem means. Most probably, I'm assuming you mean on-premise infrastructure. So if my assumption is correct, then yes, you can use traffic as a on-premise API gateway as well. Mayur, is this architecture scalable? I think for small to medium scale, the approach that I discussed is scalable. For large scale, I would remove that auth middleware and use Open Policy Agent as a library inside the API gateway itself for policy decision. But if you're operating at say Netflix scale or Google scale, then really I don't know. I mean, you have to probably get site reliability engineers and performance engineers on board. The scale is a difficult question to answer, I think. Can we do service level authorization inside APIs using SL traffic for granular authorization from the JWT, or it would be do based on path validations? Deepam, to answer your question, yes, definitely you can do that. You can do any kind of authorization as using OPA policies, right? OPA, if you look at Rego is a pretty flexible language. Once you are familiar with it, you will see that you can write policies to do any kind of authorization based on an HTTP request. But again, the thing is that there are practical challenges to it, right? Because if your microservices do not follow a uniform pattern, like for example, some microservice expects role or the username into one parameter, something else expect in another parameter, right? So there is no uniform way for you to write those policy checks. So once you adopt some conventions, once you adopt some standards for your microservices, yes, definitely you can write authorization rules in Rego, which is evaluated as part of the Open Policy Agent. Commercial API gateways need additional service level authorizations. I am not sure what is those additional service level authorizations. Will this talk be uploaded on YouTube or somewhere else? Question from Ishak. I think Harshit will be better able to answer that.
Yes, this talk will be updated on YouTube, and also you can find it in our archive page. So we will soon update it on our channel.
Awesome. Okay. Okay. One questions from Rohan. What is the difference between auth Z and auth N? Okay. Auth N stands for authentication. Authentication means establishing identity of a user or a requester. Okay. So basically, authentication allows you to determine who is this, right? And auth stands for authorization. It's basically establishing, is this person capable of doing this, right? It's an authorization decision. So authorization cannot exist of its own, right? You have to first establish an identity using authentication. Only then authorization can be enforced. I hope that answers your question.
Oh, sorry, Abhisek, to interrupt you. I guess
Yeah.
We have run out of time also, and I guess all the questions are finished.
Yeah.
So if anyone have a question, we can take one more question. The last.
I'm really happy to finish on time. Usually that is not the case with me.
Thank you, Gaurav. We got one question, last question.
Yeah.
You can take it from
We
Deepak.
use OPA for platform using traffic such as which are built using what to perform author, because at the end such platform also exposes it and keep this. Yes, I think you can do that. Traffic supports Lua based plugins, I think. Yes, so you can probably remove that authentication middleware and directly consume Open Policy Agent as a library in Traffic. Also, I think I have seen one issue on Traffic's GitHub. They are already working on some feature like that.
Okay, so I guess we're done with all the questions.
Yes. So
thank you.
If anyone has any other question, feel free to ping me on Twitter. Okay, happy to answer any questions.
Okay. So thank you, Abhisek, once again for this informative session, and thank you all participants for joining today's session. We will have our next webinar session on building a security platform with Elasticsearch by Arvind Putrevu on 20th of June. You can find the link of that webinar in the chat option. And also, please submit your feedback about this webinar, which is presented by Abhisek, through the link we have given in the chat. And hope to see you all in the future events of Nullcon. Thank you all.
Thanks, Harshit. Thanks, everyone.
Thank you.
Bye. Take care. Stay safe.